Hi, welcome to our math. Today I'm doing a series of videos on set and set notation. In this video, what I'm doing is I'm going from the set notation into the Venn diagram, shading the regions that are represented. Okay, so in this first one, I want a region that is the intersection of A, B, and C. Well, if I start with the first two, the intersection of A and B, what they have in common is this region and this region. But I also want to know what that shares with C. Well, that just brings us to this, the eye of the Venn diagram. But I want to do this a second way. I want to go through and number my regions. 1, 2, 3, 4, 5, 6, 7, 8. And I want to look at this a little more concretely. A is 1, 2, 4, and 5. What I mean by that is that the circle A is made up of regions 1, 2, 4, and 5. I want the intersection of that with B. The regions that make up B are 2, 3, 5, and 6. And then I want the intersection of that with C. The regions that make up C are 4, 5, 6, and 7. So what I need is some element that appears in everything. So A has a 1, no. A has a 2, so does B, but C doesn't. A has a 4, so does C, but B doesn't. A has a 5, B has a 5, C has a 5. What they all have in common is region 5, which is exactly what we figured out before. Oh, geez. This looks like a much more complicated example. There's a lot going on. Okay, so the intersection of A and B are these two regions. We want the union of that. Well, the intersection of union means we're adding to this. We're not taking anything away. The intersection of B and C is this region and this region. We want the union of that with, A and C. Okay, so now we have this whole kind of star, flower, center. We want that with the intersection of A, B, and C complement. Okay, so the intersection of A, B, and C, what A, B, and C all have in common is the center. But the complement is everything but the center. So we should be shading in the petals of the flower without shading in the center. Okay, so if A, let's do numbering, 1, 2, 3, 4, 5, 6, 7, 8. If A is made up of 1, 2, 4, and 5, and B is made up of 2, 3, 5, and 6, and C is made up of 4, 5, 6, and 7. Okay, intersection of A and B is 2 and 5. And we want that union B and C. So B and C have in common 5 and 6. And we want that union with A and C. Well, A and C have in common 4 and 5. And we want that as an intersection with, the intersection of all these, what all these three have in common is 5. That's the only thing they all three share. And the complement of that is everything but 5. 1, 2, 3, 4, 5, 6, 7, 8. I didn't write the 5 if you thought I was saying everything I wrote down. I did not write that 5. Just 1, 2, 3, 4, 6, 7, 8. Okay. Well, the union of 2 and 5 and 6 is 2, 5, and 6. The union of 2, 5, and 6 with 4 and 5 is 2, 4, 5, and 6. We want the intersection of that with 1, 2, 3, 4, 6, 7, 8. We want the intersection of these two, what they have in common. So this one has a 2. This one has a 4, 5, 6. 2, 4, and 6. 2, 4, and 6, which is what we had before. Okay, I hope you've enjoyed this video, learned something new. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!